Hey everybody, okay, welcome to the Science Hutch. I'm Hutch. Our very special science today is how atoms turn into ions and then come together to form ionic compounds, as we see here with our happy little heart in the middle. Let's get right down to it. Let's get rid of the ionic compound bit in the middle so we can bring these together. Let's imagine that we have element number 11, sodium, and it's in its atomic form. And what that means is when it's an atom, it's neutral. And so it has the even number of positives and negatives so that they balance out to zero charge. So we see our positives with our protons in the middle there, and then we see our negatives with our blue electrons all around the energy levels that are orange around that. If you count all those blues, you will count 11 of those to balance out the 11 positive protons. And over on the right, we see 8 positive protons in our oxygen atom, and we should count 8 blue electrons as well. So these are neutral and they are atoms. If you say atom, you're saying neutral. Okay, let's get rid of those circles and get rid of these things again. Bye. Okay. Now we're going to ionize them. Why would they ionize? Because they want to be more stable. They're fairly unstable as an atom here. Why are they unstable? Well, because they have extra electrons. Here, this sodium has this one extra electron in the third energy level. It's the only one there. We write E negative for electron. And this is a valence electron. Valence electrons are the ones in the outermost energy level. So sodium always has one valence electron when it's as an atom, and oxygen is going to have 1, 2, 3, 4, 5, 6 valence electrons in that second energy level, always as an oxygen atom. They always come equipped like that. We're going to get rid of these valence electrons, or we're going to add to them so that we can have a nice full energy level. A full energy level is going to be stable. Now, you have to know, well, what's full? Okay, so the first energy level, right there, and right there, the one closest to the nucleus, which is the middle part with the protons and neutrons, that first energy level, we write N1 for the first energy level, and it can only hold 2 E minuses, 2 electrons, and then it's full. And then you have to start stacking them on the next energy level, and that's N2, and it's full with 8 electrons. And we're not going to need, we kind of need the third energy level here with the sodium. But the oxygen doesn't even need it only has 8 electrons total. So in N3 can hold 8 electrons, but we don't need to put 8 there because sodium only needs to put one more electron in, and then its total electrons are 11. Okay, let's get this out of our way now. So now we've had that little fun discussion, and let's talk about what these are going to do to be more stable. So sodium is going to get rid of this extra electron, and if it does that, bye-bye. It can't destroy it, so the electrons still exist. It's like out here, and then it doesn't have anything in that third energy level anymore, and the second one is nice and full. That makes it stable, and it is happy. Oxygen actually is sitting here with gaps in its second energy level. It's got missing spaces here, like here and here. You see missing electrons. It could hold 2 more there. So it wants to gain electrons, and sodium wanted to lose that extra one. Well, that extra one then can come over here, and it can help oxygen become more stable by joining in with oxygen. So let's go ahead and help oxygen out, and let's grab that up and bring it on down here. Ding! Hooray! And oxygen's almost there, but it's still got that one missing spot. So what if we had another sodium atom around, and we're going to grab this one up here. Come here, sodium. Ping. And come on up here. Let's be friends. Ta-da. And you don't want that extra electron. Let's go ahead and get it out of there. And why don't you go ahead and bring that over to that oxygen? Whoop-bong, ta-da! Oh yeah. Dink. Now the oxygen is all stable, beautifully stable with 8 electrons in its second energy level. Both of the sodiums are much more stable. They're much happier this way. What did we do to them though by taking and giving electrons? You know, electrons are negative. So by putting these extra negatives on the oxygen, we put 2 extra negatives there, and now the oxygen has an imbalance of positives and negatives. It's more stable this way, but it's not neutral anymore. The oxygen still has these 8 protons, so 8p pluses. So it's got a plus 8 in the nucleus. And now if you count the electrons, it has 10 E minuses. It has 10 minuses. So when you look at the difference between those, you're going to end up with 2 extra negative charges. So overall, this oxygen atom has a -2 charge, or a 2 minus 2 charge overall. It's kind of glowing with this -2 charge because of those extra -2 electrons. That makes it not an atom anymore because it's not neutral anymore. Remember, that's the rules. So it's not an atom. We can't say atom anymore. We now have to call it an oxygen ion. And when it's an ion, its name actually will change. So it actually gets to be called oxide at that point. And all oxygen atoms will do the same thing. They'll all gain 2 electrons to be more stable. So they'll all get a -2 charge every time, and they'll all oxide ions then will be -2 in charge. What about the sodium atoms? Well, the sodiums gave away a negative. Like, they got rid of a negative electron. So what are their negatives now? Let's just kind of count them up. So now we look at their protons. They have 11 p pluses, and their negatives are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 negatives. Get rid of those ugly check marks. 10 E minuses. When we look at they can't neutralize all protons anymore. Now we end up with 1 extra positive. So the sodiums overall have a extra plus going on. And it would be like +1, but when we just have +1, we don't actually have to write the 1. We took the time to write the plus, so there has to be some amount of plus. So there's +1 to each of these. And we'll put this one down here for this second one. Now what does that do? Well, let's get rid of this math business here in a way. And let's just look at these charges here. So now we have this -2, and it's actually attracting these pluses. Opposites attract, right? So here they go. Boom. Those 2 pluses can neutralize the -2, and we're gonna get back to 0 again. And what happens when that happens? That's called a ionic bond. They're actually attracted to each other just because they have the positive and negative charges. So these are going to come over and just be near each other. Oops, I lost a little electron. Come back, little electron. Come here, little buddy. Whoop, whoop. There you go. Oh, whew. Oh, it's a little scary. Poor little electron. It's a little frightened. And then this other one, it's like, hey, I'm attracted too to you, man. So let me come over here, all right? And it's not really attracted to the other sodium, so it would probably orient like away from that other sodium. So like if we want to be a little more accurate, we could grab up this oxygen here and be like, put it like right in the middle of the 2, and they'll be happier that way. You know, we can grab this one up here like this, be like, whoosh, let's get as far away from each other as we can. Now, this makes a compound. They're not oxygen and sodium anymore. Now they're connected with these ionic bonds. They're attracted to each other. And so now what are we going to call this? We're going to call it sodium. Sodium. And then we used an oxide ion, so we're going to steal that name. So it's actually sodium oxide. With their powers combined, they are sodium oxide. And the sodiums aren't atoms anymore. They're sodium ions now. And the oxygen ion is the oxide. And so that's how you would name this ionic compound. You would just And then what would the formula be? Like, so you don't have to draw this out every time. So you would have Na is the symbol for sodium. Its Latin name is natrium. Well, that's where that Na comes from. And then the symbol for oxygen is O. And you just write them next to each other. And then you have two of those NAs. So we're going to have to write a little 2. That's called a subscript. Sub meaning under, script meaning written. So Na2O. And that would be sodium oxide. Every time, every time. Hey, thanks for hanging out with me and finding out how atoms turn into ions and how then ions, once they're made ions, they get attracted to each other because opposites attract to make ionic compounds. And we put together sodium oxide. Hey, this was the science. I was the Science Hutch. You are awesome for taking the time to figure this out. And hope you have a great rest of your day. Keep on sciencing. Bye-bye now.